In environmental geography, we studied the concept of environment, ecology, and ecosystem, wherein we studied a number of principles of ecology. One of those principles is water circulation. Water circulation is such a fact which maintains and keeps balance the ecology or the environment. It means it is water circulation which connects abiotic and biotic spheres on the earth and keeps our biosphere or ecosystem alive. What is water circulation? How it circulates and how, on the basis of water circulation, our plants and animals survive. Let us study the water circulation. The water is very important phenomena of our environment, and it is found in three states: gaseous, liquid, and solid, and it is omnipresent resource. How water circulates? Let us study. Its circulation is of two types: one through biosphere, the other through atmosphere. Water circulation starts from the soil moisture or subsurface water. Suppose this is land. Soil has some content of water which is called soil moisture, and this is surface. Below surface some aquifers are found where water is stored, and this is fresh water. How it circulates? Let us study. It could not have been circulated had there not been plants. So credit goes to these plants for this water circulation. As we have studied that there is biogeochemical cycle wherein the credit of that cycle goes to bio. In the same way, credit for water circulation goes to these plants. These plants take the soil moisture or subsurface water through their plant roots. It is in the state of film water. It comes to the plant leaves through their stem and branches, and it is present in this leaf. And when some herbivores like goat eats these leaves, that biotic water goes in that herbivores, while this water in the soil was of abiotic nature, and as it reaches this plant in leaf, branch, it becomes biotic. In goat, it becomes biotic. In goat, it may reach the goat milk, but when this herbivorous goat is being eaten by some carnivore, maybe lion, that biotic water reaches in the lion, and all these plants and animals and human body also has some amount of water. For example, in a small child, the amount of this water present in liquid state is very much, about 75%, but with the increasing age, the amount of water in human body decreases. In olden age, it becomes minimum about 50%, and after the death of that goat, that lion, that man, or any part of that food chain, that body falls in the soil, and that water again reaches the soil. So this is one pathway of water circulation, means abiotic water becomes biotic in biosphere and again returns back to the soil. This is one pathway of water circulation. The other pathway of water circulation is that due to intense or high insolation or intense heat from plant leaves, the water gets evapotranspirated, and that reaches the atmosphere takes form of cloud, and that cloud ultimately has the water of abiotic nature, and that falls down after the condensation and precipitation. Thus a cycle is again furnished, but in that cycle also this plants plays very important role. It means the larger the size of tree or plant, or larger the biomass, more rapid speed will be of the water circulation. It means this large tree or plant of equatorial forest will take more and more soil moisture or subsurface water, and it will evapotranspirate voluminous or large amount of vapor, and that's why clouds will be formed there. You might be seeing the clouds in the sky. Here the cloud patches are of small size. As you go towards the equatorial forest rain, the patches of cloud becomes of larger size, and their density also increases. Why? Now you can explain it on the basis of the rate of evapotranspiration, and again you may assess that which cloud will cause more rain, means where rain or precipitation will be maximum. Certainly the answer is in this equatorial evergreen rainforest, not in this savanna grassland. Thus the water cycle here you have seen in two forms. Number one, through this biotic component of atmosphere to the soil, but through this biotic component to the atmosphere, then again to the soil. But in both we have seen that this cycle is in cyclic form as biochemical cycle was. It is not like energy flow from the sun. And here I have seen that the abiotic subsurface water circulates through biosphere, and it is called water circulation as we have defined, and it differs from hydrological cycle. It is water cycle, but hydrological cycle is a different term. Hydrology is the scientific study of water in any state, and hydrology is a science while water is its part. Water means liquid, but in hydrology water is studied in all the three states, and it includes all the spheres of the earth. For example, hydrosphere or oceanosphere, from which due to intense solar insolation water gets evaporated. It reaches in atmosphere, takes form of cloud, and that cloud precipitates in equatorial rainforest or nearly everywhere on this earth, and that makes one hydrological cycle, because this rainwater again reaches to the oceans through surface flow or overland flow or rivers. But this hydrological cycle gets interrupted by these plants, because these plants through their root take soil moisture, and through this system of plant it reaches in the plant, then to herbivores and carnivores. Now next is the subsurface water is in abiotic state as we have discussed, and it is biotic in the plant and animal. It is taken by plant roots as film water and becomes biotic. Water circulation through herbivores, carnivore, omnivore, diversivore and decomposers that we have already discussed with the help of this figure, and ultimately reaches the land in the soil. Now, one point that we have already discussed, that evapotranspiration or evapotranspirated water from plant. This water is of abiotic nature and origin, and it makes biotic water cycle. It means these plants make cycle which is of biotic origin and nature. Next point is helps movement or motion in circulating the energy flow and biogeochemical cycle. Suppose sun gives energy, plants take it, and that calorific energy then reaches the goat and lion and again in the form of sound. In the same way, this biogeochemical cycle starts from the plant roots. Then those chemicals like calcium, potassium pass through herbivore, carnivore, ultimately reach here. In these two systems, that is energy flow and biogeochemical cycle, the water has to play very significant role because it is water that makes energy flow and biogeochemical cycle move. That's why water is very significant thing in the biosphere, and it is water that keeps our biosphere survive. And let us study the water circulation rate. Whether water circulation is distributed uniformly on our planet or it has spatial variation. Suppose this is the planet Earth and this is planet Earth. Here this is equatorial belt, and this equatorial belt receives maximum insolation and maximum heat. That heat causes as a driving force, means that heat causes maximum evaporation and evapotranspiration in equatorial region. That's why water circulation in equatorial region has the fastest rate. While moving from equator to both the poles, the water circulation rate speed decreases. Why? Because the sun rays are slanting towards pole and the intensity of heat also decreases. That's why the mechanism of evaporation and evapotranspiration decreases polewards. Hence, the water circulation rate decreases from equator to pole. To study in depth, we can divide in three groups. Number 1, maximum water circulation rate is in the forest, and in forest, in equatorial region it is maximum, then in tropical deciduous monsoon forest, then less than that in the mixed forest, then less than that in the alpine taiga forest. The second comes the shrubs, and in shrubs the maximum rate of water circulation is found in tropical shrubs, and then the temperate or sclerophyllous shrubs in Mediterranean climate ranks second. The third rate, that is very low rate, is found in grassland. The more speed is found in the tropical savanna grasses, while the less speed of water circulation in temperate, steppe, prairie, pampas, veld, downs grasses, and the deserts have very slow rate of water circulation, wherein the hot deserts have faster rate than the temperate deserts Mongolia, and the cold deserts have very slow rate of water circulation because of less amount of insolation. Thus, this is a very important principle of ecology, that is water circulation, which we have studied that in that how water starts its cycle from the soil to the plant through the food chain and again completes the soil, and how it differs from the hydrological cycle And last, we have studied that the rate of water circulation is not uniform everywhere on the earth. Rather, there is spatial variation in it.